Okay, so what's going to happen here is, let's see, I'm trying to show you how to do a least squares regression equation, and then use it to make a prediction that shows an example of extrapolation. So I'll try and do two things at once. So this is the problem that I'm talking about in the discussion form from the textbook. To do the regression equation from data, you can just collect it. I just selected the data. And you can certainly do, if you watch my other video, I did it with a spreadsheet, and that certainly works. But in case you're a little leery about spreadsheets, I'll show you this other way, since I've already got the video about spreadsheets. So in that Rossman Chance website and in that external tools, I have a link to this too. You know, in Canvas, course resources, online tools, I've got this regression equation linked, or regression applet link. So what I'm going to do is I'm going to clear out the data that's here. I'm going to paste in the data that I copied, and that gave me that. And now to do the regression equation, let's have it show the regression equation. I don't need to see the residuals, but you know, that's another part of the lesson. Here's a correlation coefficient. So I see, here's my regression equation. So because I didn't give it any values, the price is the explanatory, the X, and the quantity supplied is the Y. And here's my equation. Now I think this calculator will actually do this for us, but I should show you by hand anyway. So the question, so here's the slope. Let's make sure you understand the parts here. Let me get my, some of you are mixing up the slope. One person posted that, so here, let's get a, so this is the slope. That's my rate of change in the quantity supplied when so I better write this up here. So this is the price. This is the quantity supplied. Quantity supplied, I'll abbreviate. So the slope shows me that for every additional $1 increase, the quantity supplied goes up by 120.30. So that's on average. That's why it's okay to say 0.30. And then the y-intercept is right there. That's the y-intercept. And they wrote this backwards, right? As statisticians, for some reason, feel they need to do that. Instead of y equals mx plus b, like you learned in algebra, they write it as b plus mx. And actually, I think in the textbook they talk about, I think they use a plus bx to make it even more confusing. But just remember, the number in front of the x is the slope, and the other number is the y-intercept, where it crosses the y-axis. So we can almost kind of see with this graph that when x equals 1, so now in the exercise it asked, predict how much supply is available, or I guess is how much available when the price is $1. So if the response variable is the quantity supplied, let's see. So we know that the quantity, and that's a predicted value, so I'll put a little hat over it, equals negative 133.66 plus the times the price, or plus equals plus the price times the price times, actually I'm backwards here. Let me write the slope. So the slope's 122.3 times the price. And if the price is $1, that's going to be 122.3 times 1 plus negative 133.66. Do you see that's going to be a negative value? And we can kind of see this, the way this graph did this. I mean, I can't, see that the x-axis starts at 2. So really what we're not seeing is we're not seeing that y-intercept of negative 133.6. And when x equals 1, we can see that it's negative on the graph. Of course, we should see that here in the calculation too. So this is an example of extrapolation. Obviously, this linear model is not continuing out below what is our lowest data that they give us. Lowest data point is 3. So obviously it flattens out at some point. So that's an example of extrapolation. When you substitute in a value, X value, and try to make a prediction for a Y value when the data is outside your collected data. You don't know what's happening. Now, one of the other questions in the textbook, and I almost grabbed that one to do, but I thought this would be a better one to do because it would help me show you how to pull the values off the calculator. This other question, where is it? Here, this one. This was number 3. They asked us down here in part here. Let me get a pointer going so I can point. Where was it? 10%. Oh, here you go. The average unemployment rate in 2009 for Illinois was 10.1%. You use the value to make the prediction. So we would take 10%, substitute it in for X. And I see here, Dr. Stephen didn't reverse the slope of the y-intercept. See how that number is in front of the X? That's still the slope. So to use this equation to make that prediction, we'd replace X with 10.1 and multiply 270.07 times 10.1 plus that y-intercept and get a value. The thing I wanted you to look at is, looks to me, they didn't give us the data, but it looks to me like they have a data point that's awfully darn close to 10. Maybe it's 9 point something. And yes, 10.1 is outside the collected data. So we don't know. I mean, it almost looks like, I mean, it's hard to make a prediction with 2 pieces of data, especially since it's moving around. Correlation is only 0.57, probably statistically significant, but still it's kind of on the weaker side. So, you know, you'd expect some spread with your data points. So that's why I'm not surprised that these 2 points are down below. The next set could be above, unless it's changed, unless the relationship has changed. And 10.1, using this equation to make a prediction for 10.1% is risky because it is outside the data, but it's darn awfully close to the collected data. So you might be able to get away with it. Yes, it's extrapolation, but not what I just did with that other question on getting the negative value is not as extreme as that. So, you know, it's a judgment call. You know, it costs money to collect data. So you'll see this, you'll see people use these kind of, analysts use these kind of things in their work when they publish it. Okay, so that's yes, that's extrapolation, but it's not as risky as if I were to do it for if we had a 15% unemployment rate. That would be way out here, you know, and that chances are that data is not the same. What is this, property crime rate? I have no idea. Actually, right now, I think with the unemployment rate so high, I don't believe there's a lot of property crime. Well, maybe now, but certainly last spring when everybody was locked down, I guess there was some, but honestly, I don't remember. I don't remember hearing what that was. So, but I digress. I wanted to show you how to use the calculator to get the regression equation and the slope, I mean, in the correlation coefficient. Here's R squared. I won't continue, but you can get a lot of other stuff off this applet. Okay. All right. I guess I'll get this uploaded.